Hi, this is Takuma Nakata. I'm an interaction designer based in Kyoto, and welcome to my vvvv beta graphics tutorial. In today's tutorial, we're going to learn about closest point on SDF, which is node inside field trip, and create something similar to this one. And yeah, as far as I've done 2 field trip tutorials, and I really like how it works, and there's a lot of different things that you can do better than the vertex-based geometry stuff, and I think this way of showing stuff is one technique that you can actually do easier inside field trip. So I decided to make a tutorial. So what you can do here is it's calculating the point. So I'll change the camera to show what's happening. So there is basically a sphere that it's floating around. Oh. So there's this sphere that's floating around, and I'll move the camera a little bit. Shit, not the OBS. So there's this sphere that is floating around, and I'll just remove the sphere. So see, there's a sphere like this that's floating around, and it's calculating the closest point on SDF's surface and generating this spiky thing at that location. And what's cool is because it's not based on vertex, you can actually get this really smooth surface calculation using field trip, and I feel this is really powerful. And the reason why I came up with this kind of visual is I saw this really cool graphic from Vincent Hayes. I think he's a master of touch designer, and he was creating this really cool sort of like surface, like blobby generation thing, and I was thinking, how could I make something like this inside vvvv? And I didn't reach out the point that you can get this kind of like glowing effect, but still I can see that like implementing these in some way you could actually reach out in this kind of visual. So I decided to share this. So the patch looks like this. It's a bit complicated, but we basically don't need most of the stuff here. I mean, I'm just using them to visualize the lines. So right now it looks like this. Just small it down a little bit. But I don't need the line. And I also had some camera mounted, but I don't need these as well if you're not interested in implementing the cameras. So I will just use a default camera. And oh, where is it? It lost something, and that is the distance. Oh, I don't need this distance thing. Just delete this one. And then, oh, I disconnected this one. Dynamic buffer. Oh, it's this one. Okay, yeah, now it's back. So yeah, we basically only need this part. So this is the floating sphere, and this is the ray marching part. And if you want, we can also add the line. I think I'll follow the line part. But anyway, well, let's get started with this. So I'll just delete this one for now. I'll make a screenshot. I always forget this. Just in case. Just save this on my desktop. Okay, and here we go. So delete this one, delete this, delete this. I'll start everything from scratch. Okay, so as always, we would need a render. Come on. So we'll need a render. And then I'll need an aspect ratio. And then I'll make this one a little bit bigger. Okay, this looks good. And then I'll need a grouping node. Then I'll just delete some of them and change this one to 3 because I'll need a line and the ray marching and something else. So then I'll widen this one up. So the first thing first, first of all, let's create a ray marching basic. This will need be the shader for this, and we'll use a node called Taurus SF3D source. And then yeah, I think I'll just connect this one and see how it looks like for now. And I also add an axis and grid just so that I know where my camera is, and I'll add a camera. Camera will be the orbit. Okay, so now we got the controls. So the torus looks a little bit small, so I'm gonna change the size. So I'll increase the size. So this is the inner and this is the outer. So I'll make the outer bigger and then the inner a little bit smaller so that it comes to the shape that I really want. Okay, so I'll use this one. So this is the basic torus SDF. And then what I'll be doing, and then I'll be adding a sphere that's floating around. So add a sphere, and this one I'll be using the basic Phong point, which will basically be the DX11 effect. So it's gonna be this one. Then I'll add a sphere and connect this one here. So I'll need another group. Okay, and then I'll make this one a little bit bigger to the wide. Okay, so now the sphere is a bit too big, so I'll small it down. I hurry up the resolution to 30. And then I'll add a circular spread so that I can have this sphere moving around this torus. So I'll increase the spread count to 30, and then I'll add a vector 3D join for X and Z, and then I'll use a translate vector, and then I'll connect this one here and then put it in. This one is a translate vector, so it's this one. Okay, so now we see a bunch of spheres, which is okay. But I think I'll need to increase the radius, and I also need a depth buffer here. So in the render, go to infospector. If you don't have infospector, press Ctrl I, then change the depth buffer mode to standard. But now, yeah, now we got the depth buffer, so this is okay. So right now there's too many spheres, and I only need one of them. So I'll use a get slice spreads, which is this one, get slice spread, and then I'll change the bin size to 3 so that I can get the XYZ. Then I connect this one here. So now I only get one sphere instead of 30. And then last of all, what I'll be doing is I'll add an LFO animation, and I'll change the period to 10. And then I'll connect this one to the phase of circular spread. By doing this, I can get this phased sphere rotating around. So they're all moving like this, but I'm only taking one of them. Okay, so we're getting really close already. So next, what we'll be doing is we'll be adding a closest point on SDF. And there's a few different types. SF3, 2D, 2D, and 3D buffer, and 3D transform. For today, I'll be using the transform one. So it's going to be closest point on SDF, transform buffer. Okay, so this is the node that we're going to be using. First of all, let's add a line instead of that pyramid torus thing, because it's better if you visualize first and then see what happens. So we're going to be using line from to buffer. If you don't have this one, I think you'll need the instance noodle, was it? Is this one included in the, yeah, so it's included in the instance noodle. So if you haven't installed instance noodle, please install that one. Then what I'll be doing is I want the closest point between two things. First one is this torus, and then the second one is 3D buffer, so which is this one. But I can't connect this one because it has to be a dynamic buffer. So I'll add a dynamic buffer 3D, which is this one. Then I'll connect this get slice to here, and then I'll connect to the closest point on SDF. And once this is done, it should output the closest point on SDF already. So I can connect this one here, but this one is a 3D buffer and this one is a transform out. So I need to get a matrix position only. So instead of getting the entire transform, I'll be using this get matrix position and connect this one here and connect this one on the line from 2 2 3D buffer. And then I also need the position, the from, which is gonna be the one from the sphere. So I'll copy this dynamic buffer and then I'll connect, oh no, I don't need to copy this one. I'll connect this dynamic buffer out to here. Then I'll connect the line from to buffer to the group. So once this is done, you should be able to see the line which is pointing the closest point from the sphere on the SDF torus. So this is pretty cool. For example, if I want the entire sphere circular spreaded, so the 90 of these to be visualized, I can also just remove this one. Instead of that, connect this one here and here. Then I can also get the closest point on the SDF for the entire sphere, 30 spheres. So as you see, this is calculating, it's already giving you the closest point because this gap matrix position is outputting. To be more clear, let's do something tricky. So we're going to be using the combine SDF node, which is going to be the SF3D node. So it's this one. And then I'll add a noise SF3D, which is this one. And we'll try adding a noise to this torus to see that you're getting, so that I'm not lying. So we'll connect these two and then we'll change the combination operation to intersect round and then connect this one to ray marching basic. Let's see what happens. Okay, now we got a noisy torus, but it's a bit too noisy right now, so I'll decrease the amplitude. And then I'll also reduce the frequency. So let's see if it's working right. It's not, and that's because I'm still connecting the torus to the closest point on SDF. So let's reconnect this with the combined SDF. Let's see what happens. So as you see, like this part, I added a noise, so this part is not flat, but you can still see that it's following the closest point, so it's going up. And yeah, this part is also giving the similar result. Not sure why it's not going inside. But as you see, whatever noise you add to this surface, you can still keeps calculating the new closest point, which is quite amazing. At some point, it doesn't look like it's working well, but that's probably because, I mean, if you try out with different geometry, you should see the result. But anyways, this is what I want, so I'll give this get slice back because I only need one position. So as you see, when it goes to this point that it's going inside, you can see that it's trying to follow the closest surface. So it's going in for a moment and going out. So yeah, this is really good. Okay, so the last thing we're gonna be doing here is we're gonna add a cone SDF, which is this one. So this one is a cone, so I can add a cone. So I'll add another combine SDF. Combine SDF here, SF3D, and then I'll connect this one to here. And then I'll add a cone. Yeah, now I got a cone combined to this torus, which looks quite interesting. And I increase a little bit of combination parameter 1, because then it gives you more smooth combining result with cone and this torus. Okay, so I'll move a little bit of these. I'll increase a little bit to the wide, because I don't need to implement anything with the line anymore. And then I'll bring these down so that I can make the patch a little bit more cleaner. This one here. Okay. So next, I want this cone to be positioned at the closest point of the SDF. To do so, I need to give him the position and size and rotation. Size right now is too big, so I'm gonna make a little bit smaller. So this one could be really small, and the length could be really short as well. So I'm gonna try and map this to the the closest point on SDF. To do so, I need some values from here. And how do I do that? So first thing to do here is I need to read back. Right now this is a dynamic buffer, but to put it here I need to get a vector position. So I need to read back the transform. So that's going to be this one. Read back transform, and then I'll connect this one to the closest point on SDF. And then now I got 128 out, and that is really weird. And the reason is because the combined SDF has certain amount of spread count, and I only need one of them. So, oh wait, 3 of them? No, 1 of them. So that I only get 1 position. And then after reading this back, I'm still getting the transform, which I can't connect here. So I need to decompose these to position, transform, rotation, and scale. And to do so, I'll be using this node called decompose transform vector. And this one is, yeah, this was in default. So I'll connect this one here. And once this is connected, you can get the transform of this closest point, and you can also get the scale, but scale doesn't mean anything, so it keeps blinking. It's basically 1. And then I can also get the rotation, so I'm gonna try combine these two. So I'll bring this thing a little bit higher, and then I'll bring this read back right here, and then I'll connect the decompose translate to the position. As you see, we already got this thing on the closest point, but I think I'll need to tweak a little bit with the rotation. I'll try connecting the rotation here. So right now in default, the axis for this cone is looking upward, so I need to rotate that. And to do so, I will just add a little bit of value to this output. So I'll add plus value, and then I'll connect this one here, and then I'll connect this one back here, and then I'll add a 3D vector to the plus, and then I'll rotate a little bit of the x-axis. I think it should be at 0.25. By doing this, we already got this result. So this is what we wanted to reach for today. So as you see, we already got this cone mapped on its surface, and whenever it goes inside, it still keeps following. So yeah, this is a trick that I wanted to share. I think it's really interesting. And in vector, you can't do this kind of stuff because with like 3D geometry, it's based on vertices. So you can easily take out the vertice position, but it's quite hard to get the, the surface. You can do that by using depth buffer, but I mean that's already gives you the similar result. But doing that in field trip, I thought it would be way more easier. And you can do that like in different, like with depth buffer, you can only do that from the camera position, but with this, you can do it from wherever angles. So for example, if I reconnect this one back to all the transform and dynamic buffer, and if I increase this one to 30, because I need 30 out, you can still get this cone thing in every single surface, which looks pretty cool, I think. And like if you change this torus to sphere, SDF, you can still get the same result. Takes a bit of time to load. But as you see, so by changing this geometry, you can get this kind of like surface following effect easily by using this sphere combined SDF node. And there's different parameters in combined SDF. For example, you can change the offset. So right now it's mapped on the surface, but if you want this thing to come a little bit far away from the surface, you can increase these and change a little bit of the offset. Right now it's not working well because this combined SDF parameter is too low, but if I higher this one up, it's a little bit different. But you can also change the offset. I mean, it should work. I don't know why. I know why it's not working here, but I mean the way I set it up is a bit wrong. So anyways, it gives you an offset from the surface, so it's not only stuck on the surface, but you can get something like a little bit further from the surface. That's what this offset thing is doing. You can also change like the lookup vector. So right now it's Y up, but you can change this one in case you need it. You can also use this one, and yeah, I mean, this is it. So the rest of the thing that I added on this is I added a gradient as a 3D node, which is the one that I shared how to add a color onto ray marching basic. So I use this one, and I also use vector OP to tweak a little bit with the color. So I connected this one here, and then I changed the value here because I wanted a little bit of blue, so I added blue and red, and then I'll connect this one to the combined SDF, and then if I connect this one to the ray marching basic, you can actually get the color, like a really nice looking gradient color onto the ray marching as well. Oh, this one was the green, so I'll add this one. Then normalize. So then you can get this really nice looking colors. I don't need the gradient, but I need the constant, so I'll just change this one to constant. By doing this, you can get this really nice looking visual just with nodes from field trip and instance noodle. This part looks like a face. But anyway, this was what I wanted to share for today. Oh, this looks nice. So as you see, it's trying to calculate the closest point, and it gives you this really nice looking like moving effect. And it's really rich because it's not based on like vertices. It's really high res tracking, which I think is really cool. So if you want to get this kind of result, this is the way to do so. Yeah, that was it for today. Thanks for watching, and see you next time.